Now we'll start the next chapter, that is oxidation reduction, or otherwise known as redox reaction. We can say that. The next chapter, redox reaction. Now, redox reaction generally it takes place in where it takes place. Redox reaction. Redox reaction takes place in a battery, in a cell. Alright, electrochemical cell or an electrolytic cell, we can say that, where oxidation reduction takes place. Alright, generally in a electrochemical cell, the oxidation takes place at the anode and the reduction takes place at the cathode. Always remember that oxidation takes place at the anode, reduction takes place at the cathode. So when oxidation reduction takes place hand to hand, side by side, we can say that. Got it? So it is known as what? Redox reaction. Together it is called as redox. Reduction, oxidation. Reduction, oxidation. Together it is called as redox reaction. It takes place together. We can say that. Now, I hope you understood. Now in details about it, you will be studying in class 12 in electrochemistry chapter about the electrochemical cell and all those things. You will be studying now. Now oxidation means what? Oxidation can be defined in many ways. You have read oxidation in the lower classes also. Like gain of oxygen is called oxidation. Loss of electrons is called as oxidation. Loss of hydrogen is called as oxidation. Gain of electronegative elements is also called as oxidation. We can say that. Clear? The opposite is reduction. Reduction is gain of hydrogen is called reduction. Loss of oxygen is called reduction. Gain of electropositive elements is called as reduction. Got it? Gain of electrons is called as reduction. We can say that. You have studied all these things in the lower classes. Clear? Like C plus O2 is oxidation. We can say that. C plus O2. FeCl2 plus Cl2 gives FeCl3. That is an oxidation. Gain of electronegative element. Loss of hydrogen, H2S plus what you can say Br2 will give you what? HBr plus S. So hydrogen sulfide is losing sulfur, losing hydrogen and it forms sulfur. H2S plus Br2 gives HBr plus S. So hydrogen sulfide, got it? This reaction, it's a very simple reaction. H2S plus Br2 or Cl2. We can take it as Cl2 also here. So it will give you 2HBr plus S. So here this is oxidized and this is reduced. Here hydrogen sulfide is losing hydrogen and it forms sulfur. So this is oxidized. This one is oxidized. And this one is reduced. Why? Because bromine is gaining hydrogen. So together it is called as what? Redox reaction. This is a redox reaction. This is an example of a redox reaction, so to say. In this way, redox reaction generally takes place hand to hand. We can say if one is oxidized, other has to be reduced. Definitely. If a particular element is losing electrons, other has to gain. If it is losing electrons, it is oxidation. Listen carefully. If there is a loss of electrons, it is oxidation. And if one is losing, other has to gain. So the one who is gaining, that is called as reduction. So hence oxidation reduction takes place in this particular manner. We can say that. Clear? So in this way. Now the substance which helps in oxidation is called as oxidizing agent or oxidant. The substance which helps in oxidation. Means I should say an oxidizing agent or oxidant is a substance which supplies oxygen, which gives oxygen or any other electronegative element. It may give an electronegative element also. For example, as I said you, FeCl2 plus Cl2 gives FeCl3. I'll balance it of course. 2 FeCl2 plus Cl2 will give you 2 FeCl3. We can say that. Clear? So in this way, it gives electronegative element. It's an oxidation. From ferrous, it becomes ferric. Ferrous chloride to ferric chloride. We can say that. It's an oxidation. Clear? So this is an oxidizing agent. This is known as an oxidant. Here, this is the, what you can say, oxidizing agent. It oxidizes H2S to sulfur. That's called as oxidizing agent or oxidant. We can say that. Clear? Fine. So, or remove. So, oxidizing agent is a substance which supplies oxygen or an electronegative element or removes hydrogen. We can say that. Or any other electropositive element. Clear? So, an oxidizing agent, after what you can say, carrying out oxidation, it itself gets reduced. Remember it, very, very important. Oxidizing agent, after oxidizing other substances, it itself gets reduced. Here you can see, bromine is itself getting reduced to HBr. Cl2 is getting what you can say reduced. Alright, Cl2 is getting reduced. Clear? So in this way, so what you find is that is oxidizing agent oxidizes other substances, but itself it gets reduced. So that is called as an oxidizing agent or oxidant. The reverse is your reducing agent or reductant. The reverse is, opposite is. So reducing agent or reductant may be defined as a substance which supplies hydrogen. Here I said oxidizing agent, I said supplies oxygen. Here in case of reducing agent, I am saying it supplies hydrogen or any other electropositive element. Here I said oxidizing agent supplies electronegative element. In reducing agent, I am saying it is supplying electropositive element. So you remember in this way. This is a way to learn oxidation reduction. One, you learn it, other you remember it. Oxidizing agent you learn it, oxidation you learn it, other you remember it. It's just opposite of. Alright, just opposite of. So reducing agent may be defined as a substance which supplies hydrogen or any other electropositive element, or removes oxygen or any other electronegative element. There I said removes hydrogen. Here I am saying removes oxygen or any other electronegative element. A reducing agent, after carrying out reduction, alright, after carrying out a reduction, itself it gets oxidized. Reducing agent reduces other substances, but itself it gets oxidized. For example, here this is a reducing agent. So it itself is getting oxidized to sulfur. Here this is the reducing agent. It itself gets reduced to ferric chloride. We can say that. Clear? It's oxidized to ferric chloride. So in this way, oxidizing agent itself oxidizes other substance, but itself it gets reduced. The reducing agent reduces other substance, but itself it gets oxidized. We can say that. In this way, oxidation reduction reactions are complementary. They go hand to hand. They go hand in hand. We can say that. That is about your oxidation reduction reaction. So in a particular reaction, when oxidation reduction takes place together, we call it as this as known as reduction half reaction, and this is called as oxidation half reaction. This is called as oxidation half reaction because the total reaction is the half of it. So oxidation half reaction, this is known as reduction half reaction. Remember it. Together it is called as what you can say redox reaction. It is known as. Fine. Now next is that is a substance. I have told you already what is an oxidant and reductant. One more definition I am saying you for oxidant and reductant. That is a substance, atom, or ion or molecule. Got it? It can be atom, it can be ion or molecule, which can readily lose electrons to other substances, is called a reducing agent or reductant, which can lose electrons readily. Is called a reducing agent or reductant. Again I repeat, reducing agent reduces other substances, but itself it gets oxidized. So hence it loses electrons. Got it? While a substance, atom, ion or molecule, which can readily accept electrons from other substances, called oxidizing agent or oxidant. The one which accepts electrons readily is called as an oxidizing agent or oxidant. Listen very carefully I am saying you. Again I repeat, reducing a substance, atom, ion and molecule which can readily lose electrons to other substance is called reducing agent or reductant. Alright. While a substance which is, it can be atom, ion or molecule, which can readily accept electrons from other substances. Alright, from other substances is called as an oxidizing agent or an oxidant. We can say that. So oxidation is a process in which one or more electrons are lost. Electrons are lost. That is called as an oxidation. Got it? Reduction is a process in which one or more electrons are gained. Opposite. For that reason I said, one you learn it, other you remember it. It's just opposite. Oxidant is a substance which can accept one or more electrons. Oxidant is a substance which can accept. Got it? Now reductant is a substance which can donate one or more electrons. We can say that. So in a redox reaction, that is oxidant is reduced by accepting electrons and reductant is oxidized by what you can say losing electrons. We can say that. So that is called as a redox reaction or oxidation reduction reaction. We can say that. Now one more concept today I will teach you. You will be saying that is all things we know. Of course you know. Just I revised it. Little bit more I said you. So now today we will learn oxidation reduction in terms of oxidation number. Oxidation number. We'll read it today. What is oxidation number? Denoted by the letter ON. Oxidation number. We'll study today. Oxidation number of an element. You can write it down. Oxidation number of an element may be defined as the charge which an atom of the element has, which an atom of the element has in its ion, or appears to have when present in the combined state, or appears to have when present in the combined state with other atoms, or appears to have when present in the combined state with other atoms. Oxidation number are also called oxidation state. Very important. Oxidation number are also called oxidation state. Again I repeat, oxidation number of an element may be defined as a charge which an atom of the element has in its ion, or appears to have. Alright, when an atom is there in the ionic state, what is the charge upon it? Like Cl minus, Na plus, Ca2 plus, PO4 3 minus. Got it? Anything. So that is called as an oxidation number. That is called as that particular one. Or appears to have when present in the combined state. In the combined state, when an atom appears to have particular charge. Alright, that is called as an oxidation number. Now appears to have means, for example, let us say H2SO4. We will find the oxidation number of sulfur. So how will you do? Hydrogen is plus 2 because each hydrogen atom is plus 1. You know that. The one whose oxidation number I have to find, I will take it as X. Oxygen is minus 2. You know that. Valency. So minus 2 into 4 is minus 8. Now whole thing is neutral substance. It's a compound. It's a neutral substance. 0 is equal to 0. This is plus 2 plus X minus 8 is equal to 0. Understood? Whose oxidation number I have to find it out? I will take it as X. And the other, you know it already. I'll tell you the rules, of course. But this you know. Hydrogen, the oxidation, the valency is plus 1. Oxygen is minus 2. Same thing is. Alright. So it is plus 2 plus X minus 8 is equal to 0. Why it is equal to 0? Because you can see the compound is neutral. Compound is always neutral in nature. So total oxidation state will be 0. So you solve it this X equal to, what is that? You will be getting as plus 6. So hence the oxidation number of sulfur is 6. In this way we find oxidation number. Alright, so that is what I said. It appears to have when present in the combined state. So sulfur appears to have what? 6 in this particular compound. We can say that. Oxidation number is 6. So oxidation number are also called as oxidation state. We can say that. So this is called oxidation number. Now, what is oxidation in terms of oxidation number? Increase in oxidation number is called as oxidation. Increase in oxidation number is called as oxidation. And decrease in oxidation number is called as reduction. Again I repeat, increase in oxidation number is called as oxidation and decrease in oxidation number is called as reduction. Alright, now let us see this one, this particular thing. Now here I have written this is oxidized, so this is an oxidation half reaction. Now see, always remember that. Let me tell you the rules first, then after that I will find it out of this particular equations and I will tell you. Or let me tell you the rules. The oxidation number of all the atoms of different elements in the respective elementary state and allotropic form is taken to be as 0. Oxidation number of all the atoms of different elements, got it, in their respective elementary state or allotropic form is taken to be as 0. For example, N2, Cl2, H2, Br2, S8, O2, O3. All the oxidation number of the element is taken to be as 0. Why? Because it is neutral in nature. In the free state, it is 0. Na, oxidation number 0. Potassium 0. Cl2 0. O2 0. O3 0. S8 0. P4 0. So they are neutral in nature. So their oxidation number is 0. First of all, the oxidation number of a monoatomic ion is the same as the charge on it. Na plus. Alright? Plus 1. The charge is plus 1. Ca 2 plus. K plus 1. Alright? Monoatomic ion. We can say that. Cl minus 1. O minus 2. Sulfur minus 2, we can say that. Clear? The oxidation number. The oxidation number of hydrogen is plus 1 when combined with non-metals and it is minus 1 when combined with active metals called hydrides. Alright, for example, LiH, lithium hydride. In hydride, it is minus 1. LiH, lithium is plus 1, hydrogen is minus 1. NaH, Na is plus 1, hydrogen is minus 1. CH2, calcium is plus 2, hydrogen is minus 1. We can say that. Clear? Say this way, in case of hydrogen, it is an ordinary compound of hydrogen, we can say that it is plus 1. Otherwise, in hydride, it is minus 1 when combined with active metals. The oxidation number of oxygen is -2. We know that. Just now I did it. Oxidation number I have taken it as -2. Here I have taken it as. In most of its compound, except in peroxides like hydrogen peroxide or barium peroxide, it is -1. In peroxide, it is -1. We can say that. Next, in compounds formed by union of metals with non-metals, the metal atoms will have positive oxidation state and the non-metals will have negative oxidation state. When a compound is being formed between metals and non-metals, like NaCl, so Na will have +1, Cl will have -1. Na will have positive oxidation state, Cl will have negative oxidation state. MgO, magnesium will have positive oxidation state, oxygen will have negative oxidation state between metals and non-metals when a compound is being formed. The oxidation number of alkali metals like lithium, sodium, potassium in this way, they are +1 always. And those of alkaline earth metals like beryllium, calcium, magnesium, we can say that it is +2 always. Next is oxidation number of halogens, fluorine, chlorine, bromine, iodine, it is -1 always, we can say that. And in metal halides such as Kf, AlCl3, got it? So oxidation number, it is same thing, it is Kf means K +1, F -1, AlCl3, Al +3, chlorine is -1, same thing is. So oxidation number of halogens in halides is -1 always. In compounds formed by union of different elements of of electronegativities, we can say that. So what you find is that the metals will have positive oxidation state, or the electropositive elements will have positive oxidation state, and the electronegative elements will have negative oxidation state, we can say that. In neutral compounds, the sum of the oxidation number of all the atoms is 0. I said in neutral compound, the sum of oxidation number of all the atoms is 0 because compounds are neutral in nature. In complex ions, the sum of the oxidation state of all the ions is of all the atoms in the ion is equal to the charge on the ion. For example, here SO4 2-. So what is the total oxidation state of sulfate? Sulfate, it is 2-. PO4 3-. So total oxidation state of P and 4 oxygen is 3-. Total oxidation state. Here we will do equal to -3. Here we will do equal to -2. Here we have done equal to 0 because it is neutral. But here we will do equal to -2. Here we will do equal to -3 when we will find the oxidation number. Now next, in polyatomic ion, the algebraic sum of the oxidation number of all the atoms in the ion is equal to the charge present on it. Got it? It's a charge present on it. And remember it, oxidation number of fluorine is always -1 in all fluoride salt because fluorine is the most electronegative element. But halogens oxidation number may vary from compound to compound, we can say that. Clear? So in this way, oxidation number of fluorine in all its compound is -1. Fine? You understood now what is the rules I have said you? These are the rules I have said. Now let me find it out here. The increase in oxidation number, I said oxidation. Now fine, let us find it out. Now hydrogen, it is oxidation number is +1. Sulfur, it is -2. How it is -2? See here, +2 plus x is equal to 0. And let me solve it here. +2, if I want to find out for sulfur, plus x is equal to 0 because H2S is a compound, neutral compound. Okay, let me rub it, all these things. Let me rub it. Let me make it clear. Fine. So it will be +2 plus x equal to 0. So hence, why it is +2? Because 2 hydrogen is there. So it is +2. Each hydrogen is +1. So +2 plus x equal to 0. So x equal to -2. Hence, oxidation number of sulfur is -2. We got it from here. And here it is a free element. So oxidation number is what? Here it is +1 and it is -2. I have written it here. And here, as it is a free element, the oxidation number is 0. So from -2, see here, sulfur, -2, it becomes 0. So it is increasing. So what I said, increase in oxidation number is called as oxidation. You will see here, from -2, it becomes 0. So there is an increase in oxidation number. So increase in oxidation number is known as oxidation. And decrease in oxidation number is reduction. So here Br2, the oxidation number is 0 again because it's a neutral compound. We can say that Br2 is a compound, what can say molecule. So it's a neutral in nature. So hence it is 0. Now for HBr we'll find it out. So for H it is +1. So Br has to be -1. Why? Because +1 -1 then only it will be 0 because compound is neutral in nature. If you don't understand, I'll do it in this way. +1 plus x equal to 0. Because compound is neutral, HBr, hydrogen is +1, Br I don't know, I'll find it out. So how much it will be? X equal to, you solve it, it will become -1. So I've written -1, you can see. So in this way, what you find is that in case of Br2, what you see, it changes from 0 to -1. Bromine oxidation number changes from 0 to -1. So the decrease. So decrease in oxidation number is known as a reduction. Increase in oxidation number is known as oxidation. Same thing, let me find out here also. For ferrous, it is +2. For chlorine, -1. Cl2, it is 0. Here it is ferrous, it is again +3, and chlorine is -1. Same way, I'll take it as X and I'll find it out. Now, what you find is that here chlorine, it changes from 0 to -1. So it is oxidized. It acts as an oxidizing agent, because oxidizing agent oxidizes other substances. Itself gets reduced. So oxidation number is decreasing from 0 to -1. Itself it's getting reduced. So hence this is an oxidizing agent. Alright, this is an oxidizing agent or oxidant. We can say that. Clear? So in this way, what you find is that it acts as an oxidizing agent. Understood? So in case of oxidation, there is an increase in oxidation number. In case of reduction, there is a decrease in oxidation number. Thank you.